So we're going to do this first question of that paper. And let's start it off. So solve for the angle of theta. This is called theta, is a Greek symbol for angle. Looks like an egg like this. Just a name of an alphabet in Greek, which we used to denote angles usually. It's an unknown. So solve for theta between 0 to 360 in this equation. So what we have in this equation is 4 sine, let's start beginning with it. So 4 sine theta plus 3 cos theta equals to 0. Okay, so what we do is when it's equal to 0, kind of lucky, okay, easy solution. So 4 sine theta is equal to negative 3 cos theta. Because if it's equal to a number, it's a little bit more complex. So we rewrite this. So sine theta over cos theta equals to negative 3 over 4. Okay, and then we must remember that sine theta divided by cos theta is tangent theta. It's an elementary fact. You must remember, we can use it without quoting. Then this equals to negative 3 over 4. Okay, and then the second step is to determine the acute angle. So what is the acute angle? So the acute, okay, either an acute angle or the acute theta. So in the calculator, we ignore the negative sign. Just put arctangent of 3 over 4 to find the acute angle. So let's try to find that, please. So shift tangent, bracket 3 over 4. Ta-da! So let's say I put to 1 degree of decimal point, 36.9 degrees. Oh, let's say 36.9 degrees. So what does this acute theta mean? And what about the negative sign that we ignored just now? So these all got meanings. Okay, so let's learn it operationally. Don't worry too much about the proof and all that. It might be very confusing. I'll give you the general idea. What they try to do was to try to link the coordinate geometry to this trigonometric definition. And that is why we have this anti-clockwise and all that. If you put coordinates and points, you will see that the signs need to match. And that's how we have all those negative, positive signs and all that. Okay, already told it. Okay, please take note. Now we need to do, what we need to do is this theta. What does it mean? Okay, first we want to see this. This means cos. Only cos is positive here. A means all is positive here. Means all means talking about cos, sine, cos, tangent. This is sine is only sine is positive there. And here only tangent is positive. So if we're talking about this negative 3 over 4, from here I pick up that. Oh, this means that tangent is negative. I'm just not even writing that theta thing. Just like a keyword. Okay. That means cannot be here, cannot be here. Because these two where tangent is always going to be positive, either here or here. That means it's going to be here. Only sine is positive here means the rest are negative. Not just tangent, but cos on the top. Left corner and the bottom right corner will be not just tangent is negative, but also sine. But in this case, we're only interested in saying tangent. And therefore, that is the reason why I draw a line. Sorry, that's a horrible line. Let me just put like this. In fact, that line is actually a straight line. Okay, don't worry. Even if you draw not straight line, they won't bother with that. Just mentioning the point here like that. So that means this is the 36.9 degrees. We go from the horizontal to here. This is 36.9 degrees visually. This is the meaning of the acute angle, which we calculated by ignoring the sine itself. Or downward is always from the horizontal line because 0 degrees here. So that's why we call this the acute theta in red. Okay, the next step is to compensate or rather to calculate with the sine itself together with this acute theta. Because the angles in a quadrant, these are the 4 quadrants of trigonometry, are defined anti-clockwise like this. So this is 0, 90 degrees, 180 degrees. And the bottom here is 270 degrees. And on this side is 360 when it returns back. And then, so I'm just going to mark my line same color so you'll know what I'm talking about. But no more with that label. That's why I'm redrawing it. So it's easier for you to understand, hopefully. And then, easier for me to do this as well. That means what I'm talking about is we're moving anti-clockwise. Anti-clockwise means we start from 0 here, go all the way until here. Just the definition of that angle measurement, which I was mentioning earlier. So please remember that this one without arrow, I'm just going to write 36.9 degrees because we're going to use this to calculate that entire thing. Okay, before I do that, so I'm just going to mark here as well, 36.9, but I'm going to mark the second one with a different color just to contrast it. So we know that this one is talking about from here all the way until here. So how do we calculate these two values that are within 360 degrees? So why am I talking about this 360 degrees? That comes from the point of the question where we are at this part, because between 0 to 360 degrees. So that's why we're doing one revolution, one round. Okay, they use these terms. Every topic, or even you learn other fields, they have their own jargons. So that's revolution jargon in trigonometry here. So being that said now, okay, let's just calculate this brown one. Oh, the first answer is, so theta, sorry, is the theta is a different color first. So theta equals to, the first brown value would be, as you can see, the straight line is 180 degrees. So that is why we take 180 degrees, we minus the 36.9. Sometimes this is written in books like a block of formulas, quite unnecessary, but useful for formality only, because you can just see 180 minus that. So students sometimes waste a lot of time memorizing, oh, 180 minus theta, if this quadrant, then plus that, this, that. You have to get even more confused, yeah? Okay, just kidding. Okay, 180 is on the other one. Oh, it's wrong, not 180. Why? Because it's almost completed a full revolution. So it went to the nearest 360. It's a complete one. We just need to remove the 36.9. Quite apparent visually, I think. So minus the 36.9 degrees, likewise, like this. Dun, dun, dun. Okay, now is the calculated time. Let's put in the calculator and see, huh? Okay, let's check and see in real time. When it wrong is minus. Okay, so this is 143.1 degree. Then the word to use is or, because simultaneously you can equal to two different values. 360 minus 36.9. Huh? So 323.1 degrees. Okay, just the answer. This is how we do the two answers within 360 degrees range. Done. So I'm just going to add some bonus here, just one small bonus, just a comment. Very rarely they do this. But let me do the first part, which is quite common sometimes. Imagine they just change the wording, solve for 0 degree to theta like this, 180 degree. The equal or not doesn't matter, just work like that. So that means you would have only picked up one of those values. That means theta would have only been 143.1 degree. Done. Same thing if it was between 270 and 360, so I won't do that. And imagine if they change the wording to solve for 0 degree to, let's say they give this weird thing. They wrote 720. Rarely, or I think I've never seen them doing it much yet. Or maybe I have never seen all those papers, so I have not really gone through everything. Okay. So that means how, Oh, you. Okay, we always do the first round within 360. Not a big deal. So I'm just going to add on to that. So on this left here, on the screen, if you notice, I'm going to add a blue line. So the blue line is the next value. Oh, sorry, just exceeded that. So if you notice that, so sorry, it's not exceeded that. It means we need to go one round first, because 720 is the second round. So we can return back to this orange one like that. So as you can see, the meaning, this additional answer, 720 is the second round. Now, how do I know that? Because plus 90 each time. So 360 plus 90 is 450. Plus 90 is 540. All these are equivalent in angles. So plus 90 is 630. There's a comma there. So others I wrote below. Plus 90 is 720. So it's within two rounds. So for the blue value, oh, okay. So first we copy the first two numbers there, which is the 143.1 and the 323.1 within the first round. Then the second round, I just do a bit of calculation. The blue value I'm going to write here. So it's just add 360 because it's pointing the same as the brown one. So that means we're adding just the brown value of 143.1, which was actually gotten from here. So it's just one round after that. That's what it means. So that means you can put in calculator and check also, just in case. So 360 plus the 143.1. Okay, there we have it. So it's 503.1 degrees, keeping it to the same consistency. Yeah. And then on this side, let's say you're going to take it for the second round. So rarely they do this, I'm just mentioning in case. Okay, let's take what color? I don't know what color to choose. All I've used already. Say brown, no, not brown color, pink color. Okay, let's say from here. So we're going that same one round. First, you must just go regardless. The second one we're going looks a bit confusing, you know. Hitting it up like this. Yeah, bit of overlap there, but I think you'll know what I'm talking. It's the green one. So that means for that, it becomes quite obvious that we just need to take the green number earlier, which is the 323.1. Okay, 323.1 degrees. And then we need to plus with the one perfect cycle, 360 with it. So we'll get the second answer, one more answer. So what I'm trying to say is, why I'm doing this, one is to demonstrate what happens if suddenly they start asking like this. And then the other thing is because to understand that there are infinitely many solutions. So when you add them up, it becomes